All right, these are the answers to the review, when should I use sub or not, and then a bunch of extension questions here. So when you're looking at an integral, it can be hard sometimes to know, should I use sub or should I just do something regular? So the deal is we should always do u sub when we see one function inside of another. U sub is an extension of the chain rule, so it's a composition idea. If I see a function inside of one, that's my cue to u sub. So when I look at number one, while I see a lot going on, there's not a function inside of anything. If this had been, say, to the 5th or 6th power, then maybe, but I can just distribute this, write that as x to the 9 plus 3x to the 6th minus x to the 5th plus x to the 4th. And then I can integrate those separately. This would be x to the 10 over 10 plus 3x to the 7 over 7 minus x to the 6 over 6 plus x to the 5 over 5 plus c. So I don't need a u sub. I can just distribute that and I'd be fine. Same thing here, like there's nothing inside of anything else. I just have to rewrite, and just do my regular power rule. This would be x to the 3/2 over 3/2 minus x to the -1 over -1 plus c. And the only thing I could do here maybe is rewrite it, simplify it a little bit, let that go to a plus, either leave this as x to the -1 or write it as 1 over x. You know, there's some options I have there, but there's no u sub needed. But when I get to number 3, now it's a different story because I have x to the 4th minus 10 inside of the 5th power. I'm not going to be able to distribute that now. So this is where I'm going to bring in the u sub idea. The inside function, x to the 4th minus 10, that'll be my u. Du will be 4x cubed dx. So dx will be du over 4x cubed. So I come back over here, got my x cubed. Now I have u to the 5th times du over 4x to the 3rd. X to the 3rds cancel. I can put this 1/4 out front, u to the 5th du, and now I can integrate. So integral of u to the 5th becomes u to the 6 over 6 plus c. Then we could do a couple of things here. I can make this a 1/24th, and then instead of u to the 6, I'm going to make that x to the 4th minus 10 to the 6th plus c. And that'd be my answer there. So we come here, and we do have a function inside of one. So you start the u sub process. You go du equals 2x dx. So dx equals du over 2x. All right, you come over here, we've got x to the 3rd times square root of u times du over 2x. This x knocks out one of those, and now I have an x squared. So I can pull this 1/2 out front. I'd have x squared times u to the 1/2 du. And that x squared didn't go away. So then I'm looking at it and I'm like, well, crap, I can't integrate yet. I can't have two variables and integrate. You're not allowed to do that, at least not in this class yet. You get to Calc 2, Calc 3, maybe you can, but not in Calc 1 yet. But I look and I say, well, x squared's right here. In fact, x squared is equal to u minus 1 if I just subtract that 1 over. So what if I do that subbing in? What if I make this u minus 1, u to the 1/2 du? And then I distribute that, and I'd get u to the 3/2 minus u to the 1/2 du. Well, now I can do that, right? I can make this 1/2 u to the 5/2 over 5/2 minus u to the 3/2 over 3/2 plus c. And then the last thing I'm going to do a couple things. I'm going to flip this to make it 2/5. Multiply 1/2 times 2/5. That's going to give me 1/5 times x squared plus 1 to the 5/2. So I've resubbed in the x squared plus 1 in for the u there. Minus, and then I'm going to take the 3/2, flip that, make it 2/3. Go 1/2 times 2/3. That'll be 1/3 x squared plus 1 to the 3/2, and then plus c. So there's my, yeah, now that's a lot of work and gets kind of tricky. If you got here and you went frowny face and thought maybe I can't do it, I don't blame you. I actually, on the answer keys from years past, have had that same thing happen to me, and I stopped right there. And it wasn't until last year that I realized we could keep going. So don't get panicked there. This is much more difficult than anything an AP would throw at you. Same thing with 5. 5 is a little more difficult than what you have to worry about. The trick on number 5, I think, there's a couple ways you can approach it, but the one that makes the most sense to me is to bring this cosine up to the -3 power. Because now I see cosine inside of that -3. I'm going to do a u sub with cosine as that, which means du will be negative sine x dx. dx then will be du over negative sine x. Okay, come back over. We're going to have sine x times u to the -3 power times du over negative sine x. So this sine x cancels that sine x. The negative comes out. And this is going to go to u to the -2 over -2 plus c. So this becomes a positive 1/2 times cosine x to the -2 plus c. Put that back in for u. And there's our answer. There are other ways to do it where you could split that, bring a cosine under the sine, make that a tangent, times a secant squared and go that way. But again, this is what I think is kind of the easiest to understand. Cosecant squared is the derivative that you get when you take the derivative of negative cotangent. So this really is just negative cotangent plus c. No u sub needed. It's just remembering that. Over here, again, no u sub needed. We don't have a function inside of anything else. We're just going to distribute that. We'll get 9x to the 1/2 minus x to the 5/2. And I'm giving it the x to the 1/2 and then adding and making it into a form so that we can go ahead and integrate. This would be x to the 3/2 over 3/2 minus x to the 7/2 over 7/2 plus c. And then if I take this and flip it, it'll become 2/3 times 9, which would be 6. X to the 3/2 minus 2/7 x to the 7/2 plus c. Over here, I do have a function inside of the 4th power, so we're going to do a u sub here. U will be 1 plus x to the 3/2. Du will be 3/2 x to the 1/2 dx, which means dx will be 2/3 du over x to the 1/2. Okay, come over here. Now I've got the integral of x to the 1/2 times u to the 4th. This whole thing becomes u times 2/3 du over x to the 1/2. Now that x to the 1/2, x to the 1/2 cancel. I can bring the 2/3 out front. And then the integral of u to the 4th will be u to the 5th over 5 plus c. So now that becomes 2/15 times 1 plus x to the 3/2 to the 5th power plus c. All right, so that's that front page. Some of those are a lot harder than anything you'll see on an AP. Some of them pretty much right in line. But the idea is, when would I u sub? When I see some function inside of another one. Otherwise, I'm going to find something else to do for it.